Assalamualaikum warahmatullahi wabarakatuh, and hello, my name is Wan Muhammad Abrar bin Wan Abdul Samad. I'm a student in Bachelor of Engineering, Naval Architecture and Offshore Engineering. Today I'm going to talk about my final year project supervised by Prof. Dr. Adi Maimun Abdul Malik, entitled Vertical Vane Current Generator with Multisource Charging. So my presentation will consist of introduction, literature review, research methodology, result and discussion, and the last one is conclusion and recommendation. So now we go to introduction. So renewable energy is very important resources and it need to be maintained and meet the energy demand and replace the slowly of depleting fossil fuel. Besides, the generation of the electricity by the world today by burning of fossil fuel will produce the undesired greenhouse gas which can affect the world. So Malaysia should be blessed because Malaysia has river and ocean energy which can be the best source of environment friendly water and renewable energy. For the problem statement, in Malaysia, the average current speed is about 1 meter per second. The ideal speed to make the marine current turbine work is at least 2 meter per second. Besides, the Slovenian vertical air turbine that has been proposed by previous study, it has two main drawbacks, which is low torque and low TSR, low speed TSR, making it difficult to integrate this rotor with the generator. So the objective of this research is to develop an electrical system for vertical vane current generator with multi-source charging using MATLAB. The second one is to evaluate the performance of the electrical system in generating electricity for the hybrid system. So the research scope is to develop the hybrid system consists of photovoltaic current turbine and generator using MATLAB. And the second one is to evaluate the performance of the electrical system in generate electricity by the vertical vane current generator, solar panel and generator to fulfill the demand for one rural household. Okay, the significance of this study is the simulation of the model can be used to estimate the electrical energy produced by the hybrid system. And then it also can the ability of the many sources of the energy will increase the reliability and power produced in cost-effective way. Okay, now we move to chapter 2, literature. Okay, now we go to hybrid renewable energy system. So hybrid system is the combination of two or more renewable energy with non-renewable energy or with renewable energy sources. So below we can see the example of the hybrid power system. So now we focus on low speed vertical edge turbine by Omar Yaakob in 2008. He said earlier, solar turbine has been proposed to harness the current energy, but in 2015, Atif Abdul Salim said there are two problems with the type of the turbine, where it has low torque and low tip speed ratio (TSR), which make this rotor difficult to integrate with the generator. And also by the Fatima Behrozi in 2013, she said that low speed vertical edge turbine with the Marvel modification in having two arms to increase the torque and self-adjusting blade to reduce the drag seem to be the practical design to harness energy system at low speed current in Malaysia. So the component of photovoltaic system consists of photovoltaic cell. It represents the fundamental power conversion unit. So it's usually they made from semiconductor and convert the sunlight to electricity. Cell produce very small of energy and power. So to increase the power output of the photovoltaic, the cell must be connected together to form a larger unit we call module. So module we can connect in parallel or series to form larger core panel or array to produce electric power that meets the almost energy demand. Now we go to energy consumption. The consumption load of the and nominal power are very important factor that play important role in designing the hybrid system and to evaluate the performance of the hybrid system. So according to Atif Salim, the typical power consumption for the rural household are shown in table below. Okay, now we move to chapter 3, research methodology. So this is my methodology flowchart, which I start my study with collection of data of current turbine, solar panel, and DC generator, and then I start to modeling of the vertical vane current generator, solar panel, and the last one is modeling of the DC generator. Then start to simulate the hybrid system to get the result. So this is my Gantt chart for UGP 1 and 2. Okay, for the vertical vane current generator modeling, first we need to determine the turbine dimension to get all of these parameter. So this is the input data we need to use in the simulation. So for the current speed, we use 0.5 to 2.5, which is the average current speed in Malaysia. So the water depth used in 2.5 above. So we also use the parameter that we get from the prototype, which is bucket diameter, bucket height, and total diameter as an input power, which is the input fire formula we can see there. So this is the turbine block, the arrangement of the turbine block in the simulink. Okay, so from the mechanical power output of the turbine, we need to convert it to electrical power. So we use the generator. So the generator we use is low RPM, permanent magnets synchronous generator, PMSG, to simulate the power output. This is how the generator look like in the simulink. Okay, now we move to second system, which is solar panel. So solar panel get the input energy from the solar radiation. So in my study, I use 3 different irradiance intensity to see the performance of the solar panel. So 2 equation was used and consider to calculate the voltage, current, and power for the solar panel. So this is the first formula you can see. So the second formula we need to consider is solar generated current. So you can see the formula in the slideshow. So this is the some setting about the cell characteristic of the solar panel. So the number series of one solar panel consists of 36 of series cell. So 36 is the standard number of the cell in the one solar panel. So this is how the arrangement of the model looks like in MATLAB Simulink. Next is diesel generator modeling. So diesel generator is used as the alternative to charge the battery if there is no sunlight or the current turbine is not working under maintenance. So the generator model is using the direct current, which is the ideal way to charge the large amount. So in the simulation of the diesel generator, the generator is set to turn on at time 12, which is after the consumption of the load, to see the battery discharge and to see the generator charging the battery. You can see how the arrangement of the DC generator modeling in the slide now. So next is battery bank. So type of the battery is lead acid, and then the rate capacity of the one battery is 250 ampere hour. Okay, this is how the battery bank look like. It consists of 4 battery. Okay, now we move to the result for the hybrid system. Okay, the first one is vertical vane current generator. Okay, from the table you can see in the slide, with different current speed I'm using in the study, which is 0.5 to 2.5, it shows the increasing number of RPM, which is from 3 point something to 13.68. So the increasing number of the RPM will also increase the mechanical power for the turbine, and this will produce higher number of power generator power with the increase of the current speed. So the daily average, we times the power generator with 24 hours to get the energy in watt hour. So we can see from the 0.5 to 1 current speed, the generator cannot produce enough power, which is 5 kilowatt hour as the requirement for one rural household. So if I can show you the graph to make it more clear. Yeah, from the graph you can see with the increasing current speed from 0.5 to 2.5, the generator power will increase significantly. So we can see from the result and the table and from the graph, the current speed is the main factor that will affect the power produced by the vertical vane current generator. So as the result, it shows the generator power can generate electricity from 2.5 to 0.5 but meter per second. But at 0.5 to 1 meter per second, the power produced very small and cannot fulfill the demand for one rural household. Okay, next is solar panel. For the solar panel, we can evaluate the performance using the IV and PV curve. Okay, for 1000 watt per meter square irradiant intensity, from the IV curve, we can see the voltage VOC, open circuit voltage, is 20 volt with the minimum current of 0. While the maximum, which is IMP, showing value of 3.13 ampere, and the voltage VMP is 16 volt. Okay, from the PV, we can evaluate the maximum output power, which showing in the graph is the highest maximum output power of the solar panel is 50.08 watt. Therefore, considering the ability of the sunlight and irradiant intensity in the Malaysia only for 11 hours, so one solar panel can produce 550.88 daily watt hour for daily. Okay, and then I'm decrease the irradiant intensity to 750 and 500. So from when I'm decrease the irradiant intensity, we can see that the IMP and VMP for the solar panel also decrease. And on the other hand, we also can see that for the power output of the solar panel also decrease with the decreasing of irradiant intensity. So the performance of the solar panel I summarize into this table. So we can see from 500 intensity to 1000. So this is the summarized of power produced by the vertical vane current generator and solar panel. 0.5 current, the number of solar panel needed to fulfill the balance of power required is 10 number of solar panel, and then for 1 meter per second current speed, it need 7 number of solar panel. But for 1.5 above, it doesn't require any solar panel because it's already produced higher and enough energy. And last but not least is the diesel generator, which is used as a backup system to charge the battery bank when there is no sunlight or the vertical vane current turbine is under maintenance. So we can see from the figure in the slide, there is SOC, stand for state of charge, current, and then voltage, and the last one is battery power. Okay, as I mentioned before in the methodology, there is load consumption between the time 2 to time 12. That's why we can see the state of charge of the battery is decreasing within the time 2 to 12. And also, we can see from for the current and voltage, there is increase in the current for the time 2 and time 12. That means there is load consumption, and the voltage is decreased, and also there is load consumption there, and also for the battery, and the diesel generator is turning on at time 12 to charge the battery. and we can see from the result the current values turn back to zero. That means there is no load consumption, and the voltage is increasing. That means the battery is charging by the diesel generator. And with the supply of 50 ampere of direct current by generator, the result indicates that each battery with the rated capacity 250 ampere hour, it can be charged within 8 hours. Therefore, the diesel generator can be accepted as a backup system to charge the battery to sustain and produce sufficient amount of power output to the household. As the conclusion, the study to evaluate the performance of the vertical vane current generator with multi-source charging is achieved. By using MATLAB Simulink, I can predict the performance of the hybrid system consists of the vertical vane current generator, uh, solar panel, and diesel generator. And the result from the study indicates that the hybrid system can produce enough power for the one household, which is 5 kilowatt hour per day. For recommendation, I would like to recommend the study how to increase the speed of the current by using technique of argumentation or diffuser. Besides is to varying the solar cell temperature to obtain a more accurate result for the solar panel. And last but not least is by doing experiment to validate the MATLAB Simulink result. I think that's all from me. Thank you very much and have a nice day.